With the help of state equation and output equation, we look at such a circuit. How to solve the zero-state response for IR? We need to use the substitution theorem so as to obtain state equation. The capacitor and the inductor is replaced by the voltage source and the current source respectively. We draw the equivalent circuit like this. It is a resistive circuit. There are many methods if we want to find IC and UL. Here we might as well use the node method. Assume it's a reference node and so this is only one variable. We write that its self-conductance is 1 plus 3. So the left part is 1 plus 3 times U, which is current flowing out of the resistor. The right part of the is current flowing flowing from the sources. That is so we can solve the U. After get U, we can get IC. We need to write KVL in this path for solving IC. Thus IC equals minus UC plus U minus 1 over 1. So it is it's relatively easy for UL because UL equals U in the circuit. So we complete the listing of the state equation. Specifically, it is like this. In addition, we might as well write the output equation with the output variable IR. For the identified U, IR equals 3U. So we have next we can use the matrix A to solve its characteristic roots. That is like this. Expand the determinant. We can get that we know they are equal real roots, that is. So we know that any branch variable in the circuit is critical damping. In addition, we also need to know the steady state value of IR. When the circuit is in steady state, the capacitor is open circuit and the inductor is a short circuit. We need to draw the steady state equivalent circuit. It's clear that the steady state value for IR is 0. Having these two basic knowledge, we can write that the general solution of IR is with the form of A1 times e to the power of minus t plus A2 times t times e to the power of minus t. Next, we need to find the initial value of IR and the initial value of dir dt in order to find the underdetermined coefficient A1 and A2. We need to draw its 0 plus equivalent circuit for solving the initial values. Because the circuit is a zero-state circuit, so the capacitor is replaced by a voltage source and the inductor is replaced by a current source. In the 0 plus circuit, we can easily get that IR0 equals 1 over 1 plus 1 over 3 equals to 0.75 ampere. In order to find dir over dt t equals 0 plus, we need to use the output equation, differentiate the equation. We know that dir over dt equals 0.75 times duc over dt minus 0.75 dil over dt. We find the 0 plus value for the two sides of the equation at the same time. So we need to find IC0 plus and UL0 plus. It's easy for the problem. IC0 plus equals 0.75 ampere, and UL0 plus equals 1 over 3 times 0.75 equals 0.25 volts. We know that in the expression it is equal to 1 over C times IC0 plus, and it is equal to 1 over L times UL0 plus. Substituted IC0 plus and UL0 plus into the equation, we can get IR dir over dt t equals 0 plus equals 1.5 ampere per second. With this initial value and this initial value, we can substitute them into the general solution. So the expression A1 equals to 0.7 and A2 equals to 0.75. So the expression of IR can be written as the form of 0.75 times 1 minus t times e to the power of minus t ampere, t is greater or equal to 0. So we finish the analysis of the entire circuit. Take a look. The process of solving any one branch variable of the second order circuit is similar to the analysis of the first order circuit. We analyze a series of resistive circuits. We can also call it the three elements here. But here the three elements are more generalized. That is how the circuit change, steady state value and 0 plus value. About the change of the circuit, we use the state equation. Steady state value is found by a resistive circuit. About 0 plus value, we need to solve the 0 plus value of variable and 0 plus value of the derivation. We use the output equation when solving the 0 plus value of the derivation. So as long as you master the basic concepts such as the law of switching, the state equation, and the output equation we taught before, the response of any branch variable of the second order circuit can be obtained by this generalized method. And the whole solving process is obtained by solving a series of resistive circuits. The physical concept of the solving process is very clear. Please be familiar with it and master this kind of method.